Our lesson today is all about introduction to problem solving. So the first topic related to introduction to problem solving is inductive and deductive reasoning. Let's talk about inductive reasoning. Inductive reasoning is the type of reasoning that forms a conclusion based on the examination of specific examples. So that is called inductive reasoning. The conclusion formed by using inductive reasoning is a conjecture or a theory, an assumption based on the collected evidence. So, in short, inductive reasoning is the process of reaching a general conclusion by examining specific examples. So, inductive reasoning is very useful, especially in science and engineering, because you are trying to come up with a theory or a conclusion based only on very specific experiments. So you can't do all experiments, but you do a few, and from the results of the few experiments that you do, you can somehow create a conclusion which may apply generally to all other examples and all other experiments. So, in short, inductive reasoning is general conclusion derived from specific examples. So, for example, use inductive reasoning to predict the next number in each of the following sequences. For example, letter A, 3, 6, 9, 12, 15. So this is just a very specific number of numbers. You don't really see all numbers involved in this sequence. However, from this specific number of examples, you can make a prediction or a conclusion that the next number is also 3 steps or plus 3 from the previous number. For letter A, I believe the answer here is 18. So for letter B, the answer I believe is from 1 to 3, you're adding 2. And then from 3 to 6, you're adding 3. And from 6 to 10, you're adding 4. And then you're adding 5. So you can somehow conclude that for the next number, you have to add 6. So I believe the answer for letter B is 21. For letter C, I can see a pattern that you're multiplying 2 after each number. So I believe the answer is 16 times 2 or 32. Let's check our answers. So let's look at another example. So in this example, you use inductive reasoning based on a table of data. So a tsunami is a sea wave produced by an underwater earthquake. The height of a tsunami as it approaches land depends on the tsunami's velocity. Use the table below and inductive reasoning to answer each of the following questions. What happens to the height of a tsunami when its velocity is doubled? What should be the height of a tsunami if its velocity is 30 feet per second? So, based on these very specific results from a very specific experiment, we're trying to derive a conclusion on the relationship between the height of a tsunami and the velocity of the tsunami. So letter A, when the velocity doubles, such as going from 9 feet per second to 18 feet per second, the height increases from 9 to 36. You can see that in one of the data here. No? That is, the height is quadrupled. From the table also, we can see that the height of the tsunami traveling at 15 feet per second is 25 feet. So from part A, doubling the speed from 15 feet to 30 feet quadruples the height. Therefore, the height of a tsunami traveling 30 feet per second is 100 feet. So you're analyzing your data, you're trying to come up with patterns, and from these patterns, trying to come up with a conclusion. So a counterexample. A counterexample is an example that disproves a conjecture. For example, find a counterexample to each of the following statements. Letter A, my sisters are mammals. My dog is a mammal. My cat is a mammal. The horse in the field is a mammal. By inductive reasoning, all animals are mammals. Ooh, so what's the counterexample to this? So let's look at the answer. Letter A, my pet turtle is not a mammal. Well, there are many other counterexamples. So you're just getting coming up with an example that disproves or uh, a conjecture. So let's look at letter B. 12 is divisible by 4. 20 is divisible by 4. 36 is divisible by 4. By inductive reasoning, all even numbers are divisible by 4. But we know this is not true. And you can come up with a counterexample. Let's look at what. Yeah, 6 is an even number, but it's not divisible by 4. And again, there are many other counterexamples. So that's what a counterexample is. Now let's look at deductive reasoning. So what's the difference between the deductive and inductive reasoning? So for deductive reasoning, it is a process by which a conclusion is reached based on premises that are assumed to be true. So you have premises that are assumed to be true, and you come up with a conclusion. For example, so each of 4 neighbors, Sean, Maria, Sarah, and Brian, has a different occupation: editor, banker, chef, or dentist. From the following clues, determine the occupation of each neighbor. So Maria gets home from work after the banker but before the dentist. Sarah, who is the last to get home from work, is not the editor. 3, the dentist and Sarah leave for work at the same time. 4, the banker lives next door to Brian. Now, the point here is that we are assuming that all of these are true, all of these premises. And so our entire conclusion is based on only these 4 statements, right? And also the fact that there are 4 people and they have different occupations. So we're looking at this very specific example to come up with a very specific conclusion. So this truth belongs only to this set of truths. Okay, so that's deductive reasoning. So you have, for deductive reasoning, you don't have to worry about only having specific examples to come up with a general conclusion. In fact, what we have here are general examples or general truths, because in the first place, the truths are limited to only 4, right? Statements. General truths for a very specific conclusion based only on a limited amount of general truths. So yun ang difference ng deductive at inductive. So this, in order to solve this puzzle, you have to employ this strategy. So from clue number 1, Maria is not the banker or the dentist. So therefore, in the following chart, you can write X1, which stands for ruled out by clue 1, in the banker and the dentist columns of Maria's row. So in order to solve such problems, it's best to create a table where the columns represent the professions and the rows represent the people. And one by one, you read each clue and you try to figure out, to rule out possibilities based on the clues. And from the first clue, we are able to rule out that Maria is not a banker or a dentist. What does the first rule say? Maria goes home from work after the banker but before the dentist. So definitely Maria is not a banker or a dentist, right? Because it's implicitly stated here. From clue number two, Sarah is not the editor. Why? What does clue number two say? Ah, yeah, literally says that she is not the editor. So you rule out that she is not the editor and at the same time, she's not a banker. Why? Because we know from clue one that the banker is not the last to get home, and we know from clue two that Sarah is the last to get home. Therefore, Sarah is not the banker. So the more X's you make, then the better, no? From clue 3, Sarah is not the dentist. So you write X3 for this condition. There are now X's for 3 of the 4 occupations in Sarah's row. Therefore, Sarah must be the chef, right? So you are for sure now that Sarah is not a chef because for Sarah's row, there are X's for editor, banker, and dentist. So you place a check because Sarah is the chef. None of the other people can be the chef. Therefore, you write X3 for the other items in the row in the column for the chef. Diba? Kasi we already know that Sarah is the chef. From clue 4, Brian is not a banker. Write X4 for this condition. And then you will eventually find that there are 3 X's for the banker's column. And so we can say that Sean is the banker. And basically, if you follow this process, it will make this puzzle quite easy to solve. Well, the point is you are only dealing with the 4 clues, very general clues, and then you're coming up with a specific example, a specific conclusion, I mean. So that's all, right? So I hope that you learned something today about uh, problem solving.